Right, we're starting lesson 6-7 today, and common logarithms is the title. You may remember that common logarithms are base 10 logarithms. Common logarithms are typically written with no base showing, and I think we've talked about this in the past. If I'm going to evaluate this log, if there's no base showing, it's understood to be 10. So my answer to this, well, you tell me. What would the answer to this be? 10 to the what power would equal 100? Yeah, so my answer is 2. Give me the one-word definition of a logarithm. An exponent. All right, so in exponential form, this literally means if I take a base of 10, I have to raise it to some power to make it equal 100. And you just told me that that power is 2. That's what it means to evaluate a log. And today's lesson is all about base 10 or common logs. This slide is important because it shows where we've been in previous lessons. So just a quick review. This is called a log equation. And the rule of thumb is for log equations we convert, well, let me just go and fill in the blanks. We changed log equations to exponential form. Log equations need to be changed to exponential form. So let me just give you a quick example. In exponential form, this says 3 raised to a power that equals 27. So again, solving a log equation means you discover what that power is. So what would the answer be to this easy equation? 3. But the easy, nice way to solve log equations is to convert them, make them into exponential form. Well, that's where we were. Where we're going today is we're going to be solving exponential equations. Well, what do you think we're going to do now? We're going to take exponential equations and we're going to turn them into log form, so it's just the reverse. We need to change exponential equations to log form. So if you keep this in mind, you'll always help yourself. Log becomes exponential. Log becomes exponential to solve. Exponential becomes log to solve. This next slide has been deleted. You shouldn't have it. We're just going to skip these problems. So don't worry about that. Your number 1 really is this. Okay, I know it says Roman numeral 2, but I've changed my slides. So let me give you some examples of what you're going to be doing in these problems. These are exponential equations. The answer is really this exponent. To solve exponential equations, I'm going to convert them into log equations, and that looks like this. I'm going to do log, the common log, on both sides of the equation. This is going to be a common, this process is very repetitive. You're going to do this basically every single problem. As long as I do the same thing to both sides, I'm equivalent, and I did. I did the log on both sides of the equation. You may remember, hopefully you do, that a few lessons ago, we discovered the power property. The power property says that exponents in log form can be brought down and can be used as factors. So I need to apply the power property. And that's going to be a repeated process as you go through this lesson. All right, well now I'm solving for x. And I've got multiplication here, x times log 6. Well, how do I undo multiplication? With division. So the way I can undo, if I want to isolate x, I can undo multiplication times log 6 with division by log 6. But if I divide log 6 on the left, I also must divide by it on the right. So essentially these are going to cancel, And now you're going to turn to your calculator, and you're going to hit the log button, log, put in 40, divided by, hit the log button again, put in 6. Just make sure you close the right parentheses after 6. The left parentheses is provided, and then you have to close the parentheses. All of these are going to be rounded to the nearest 10,000th, which is 4 decimal places. So let me see what we got. 2.0588 rounded. So raise your hand if you were able to get that. Very good. So analyze what we just did, because that basic process is going to be done over and over and over. The problems vary just a little bit, but basically this is what we're going to do. All right? Let's try another one. So this is an exponential equation. I'm trying to find a. I'm going to do log on both sides, just like the previous problem. So I'm giving you a good template for how to show your work. Okay, this exponent needs to be brought down as a factor. That's called the power property. So a plus 2 log 2.1 equals log 8.25. Okay, multiplication can be undone with division. Making these cancel, I'm trying to solve for a, so I get a plus 2 on the left side, and now you turn to your calculator and you're going to do log 8.25 divided by log 2.1. And Kyle, can you go ahead and give us that decimal? 8441, and then it runs on and on. So here's what I would do. You don't have to write that decimal down at this point. I would just leave that decimal in your calculator, and to find a, we just need to subtract 2 from that number. So our answer for a should be 0.8441. Who got that right? Great. Do you have any questions? Now's a great time to ask. You can't practice what you don't understand. And if you haven't discovered yet, algebra is a lot about practice. All right. Now this one's a little different. What do you notice right away that's different? Yeah, we have the variable b on both sides of the equation. So this one's a little more involved, but we start off the same way. Log on both sides. Power property, but this time it's going to be on both sides. We're going to bring the left exponent down. And I'm going to bring the right exponent down. Once again, this is an application of the power property of logs. Whenever you've got the, that's not a 6, that's a B. Sorry, I can't read my own writing. Whenever you have the variable on both sides like this, we already discovered because the exponent contain, each of the exponents contain b's, I'm going to have to do the distributive property. I didn't have to do that before, but just think of distributing log 11 to both of these. Okay, log 11 times b is just b log 11. Literally means b times log 11. And then do the same thing with negative 3. That's negative 3 times log 11. So the reason for doing that is to solve for b, we already know this, b has to be on one side of the equation. Well, right now I have b terms on either side of the equation. So I need my b terms together on one side, and if the term doesn't have a b, it needs to be on the other side by itself. So I'm going to just describe what I'm about to do, just make sure you understand. I'm going to move b log 5 to the left with subtraction, and I'm going to move 3 log 11 to the right with addition. B's on one side, non-b's on the other. So without showing that step, this is what it's going to look like. The reason for getting my b terms on one side is because now I can factor. Remember GCFs? Well, if you look at the left side, these two terms have a GCF. Well, what is it? B. So let's factor out b, and when we factor out b, we're left with log 11 minus log 5 times our GCF of b. Okay, now we're back to what we were doing basically before. We can undo multiplication with division, but now we're going to have to divide by this whole thing. So I'll show you in just a minute how you can use your calculator with parentheses and make this a lot easier for yourself. But let me just show you the step first. I'm dividing by log 11 minus log 5 on both sides to get b by itself. I'll give you a chance to make sure you get that down. I'm going to go to a new screen, and I'm going to just make sure you're using parentheses correctly, so you can just do all of this on one line. Okay, so in your calculator, you're doing 3 log 11, and then you hit divided by, and then we need parentheses. Log 11. So if you do exactly what I'm doing in your calculator, it should work. I'm doing parentheses because this entire denominator needs to be in parentheses, but the numbers that we're doing the log of are also in their own set of parentheses. So it looks like this. Is that 5? So make sure you have basically double parentheses on the right. And you should be able to hit enter there and get your answer rounded to 4 decimal places. Josh, what did you get?
I got 9.1227.
That sounds very familiar. Who got that right? Good job. You guys are catching on quickly. Any questions? Do you think you understand the process? It's very repetitive, so once you've done a few, you should catch on and speed up, do them pretty fast. What's my first move here? Let me get Samantha. Okay, log on both sides. Okay, Micah, next. Power property?
Yes.
So what would that look like? Well, this exponent, the power property says take this exponent and bring it down and make it a factor. X squared log 7. Okay, and I've got multiplication right here. So if you want to, you can do parentheses to show the multiplication. So what undoes multiplication? And what am I going to divide both sides by? Log 7. And you're ready to go to your calculator. And you're going to do log 20.42 divided by log 7. And Landon, tell me what you got for that. Log 20.42 divided by log 7.
1.5
0, 1, and of course it runs on out there a little ways. Don't erase that, just leave it in your calculator, and now we need to do the square root. And so the easy way to do square roots, if the number's already sitting in your calculator, is to hit this button, the caret, little up arrow, but it's very important that you put 1/2 in parentheses. Raising a number to the 1/2 power is the same thing as doing the square root of a number. Now what do we have to remember to do when we do the square root of both sides? Plus minus. So Kate, what'd you get? 1.2450. Who got that? Okay. Any questions? Any questions? You guys are doing great. Well, what are we doing now? This is Roman numeral 2 for you. What's the difference? Yeah, these are inequalities, but the good news is you solve them the same way. It's just that our answer, instead of just one number, it's going to be a bunch of numbers. So I go about this the same way. I do log of both sides. BJ, what's next? And that's an application of what property? Power property. Good. All right, August, what's next? Divide by log 5 on both sides. So give me that decimal, Campbell, what is log 33 divided by log 5?
2.1725.
Okay, and I would just leave that in your calculator. To get our answer for n, we just need to divide that number by 4. So Trent, when you get that, what is that?
I got 0.5431.
So my answer now, n is greater than 0.5431. Who got it? Any questions? Okay, I think the next one you need to make a slight adjustment because I accidentally wrote it down as 4 times p. It should be 4 to the p power. So make that adjustment on your notes. Instead of 4 times p, make it p as an exponent. Okay, I'm going to give you about a minute, and I want to see if you can come up with the answer, and then we'll come back together. All right, so once again, we're going to do log on both sides. And I'm going to use the power property on both sides. Okay, and here we have p on either side of the inequality. So this is where I noticed some of you weren't getting it. You got to do the distributive property. So just think log 6 times p, that's p log 6. Negative 1 times log 6, negative log 6. And now you want to think about getting p terms on one side and non-p terms on the other. So that looks like this. I'm going to move p log 4 to the left with subtraction. And I'm going to move log 6 to the right with addition. At this point, you can factor out p. And you're going to be dividing log 6 by this parenthesis, okay? Because I'm going to be dividing both sides of my inequality by log 6 minus log 4. So in your calculator, to get your answer, you will do log 6 divided by, and make sure you put all of this in parentheses. Obviously, the numbers already have to be in parentheses, but the entire denominator needs to be in parentheses. And this is the answer you should come up with. All right, any questions so far? Okay, we're almost there. The easy part, you'll run through these real fast. The directions say, this is Roman numeral 3 for you, express each logarithm in terms of common logarithms, then approximate, again, to the nearest 10,000. It's 4 decimal places. This is going to utilize a very important formula in terms of logs. It's called the change of base formula. It's very easy to use. Easy to remember. The change of base formula is what you're going to be applying when you do these problems 33 to 38. Here's what it basically looks like. With your calculator, it's easy to remember because the numbers stay in the same order that they appear. You're going to do log and then put in the top number, 7, divided by log again and then put in the base. So the numbers stay in the same order that they appear in the logarithm. Log top number divided by log base, and that gives you a long decimal, but we just need to round it to 4 decimal places. So Josh, what is that?
1.7712.
Very good. Okay, and I just have one more because these are pretty simple. Try that change of base formula for letter B. And Jackson, let us know when you get that.
1.1673.
All right, show of hands if you got that right. Okay, I think you're ready. And the assignment, you got some time to get started on it. I'll be here to help you. I'll call out some answers in just a minute, see if you are getting them right.